So thanks friends for joining in today. And today we are trying to discuss one advanced topic in statistics. Statistics. This is also basic statistics only. Sorry. So it is called hypothesis testing. So it is really a hypothesis testing. So guys, you understand what is hypothesis first of all. We learned hypothesis and all in physics and all. We used to learn some hypothesis and all.
Yes.
So what is the meaning of hypothesis, guys?
To visualize the output of the thing, we need to assume something, the assumptions.
Assumptions, yes, it is near to assumptions. So if we are making some assumption about any business thing, that average age of nurses in our hospital is 35 years. Suppose we are assuming without measuring, like without taking interview of nurses, we are assuming just seeing by their faces that average age of nurses should be around 35 years. So that we can test statistically. How can we test? After that, we take their interview. And what data comes, with that data, we try to either reject the hypothesis or accept the hypothesis. So if data says that average age is 40 years, then you reject your hypothesis. That is original hypothesis. That is called null hypothesis. So you reject it. If it is 35 plus minus 6 months, then you accept null hypothesis. Both you do. So how to do that? There are simple formulas to do that. We'll very interesting topic and very important and very fundamental topic is statistics. Okay, so we'll discuss all of it. Okay, so these are the topics that we'll cover, like confidence interval, credible interval, point estimate, interval estimate, hypothesis testing, applications of hypothesis testing, null and alternate hypothesis, how to formulate null and alternate hypothesis, making a decision, critical value method, p-value method, type 1 and type 2 error. So these are all we are going to cover. Either today not possible. Today then there is some numerical part also to it. So numerical will not be able to cover today. So numerical will be in next lecture. So today we'll cover the theory part. Theory is equally important. Okay. So after that, after this lecture, next lecture will be hypothesis. This lecture will be hypothesis testing theory. Next lecture will be hypothesis testing numericals. The numerical worked out examples, and after that third lecture from today will be something called correlation and related concepts. So that these are the, so I'm skipping for now, and after that regression, and then we'll finish our statistics course, basic statistics. Okay, so now guys, you know these doctors and all, right? So if you go for any treatment, so suppose you are having say, so what treatment I should take? Suppose TB you are having, like not some you are having TB, some XYZ person is having TB, tuberculosis. Okay, so it's a kind of little severe disease. We are like, so like person can if it becomes severe, person can die. So in early stages, if somebody goes to doctor and it takes X-ray and everything, and doctor it is like the guy tests positive for TB. Now you go for the 2-3 possible treatment. Doctor will suggest each treatment has a different cost. So doctor will suggest that if you take treatment number 1, your chances of cure are 99%. Treatment number 2, chances of cure are 95%. Treatment number 3, your chances of treatment 3 is the cheapest treatment, and chances of treatment are chances of getting cured are 80%. I'm giving a hypothesis. I'm not a doctor. Okay, I'm just giving an example, a hypothetical example, some cooked up example. Okay, so these are the 3 treatments. So doctor will always talk in terms of probability. Even if you are taking the costliest treatment number 1, doctor will tell 98% chance of getting cured. Still, 2% he will keep with him. That 2% chance not getting cured also. So doctor will always talk in like somebody is in a critical stage of cancer. So doctor cannot say, doctor is not God, okay? So doctor will say that there is a 80% chance that he will survive only 6 months, next 6 months. So doctor will talk in terms of chance. So this is chance. Doctor will, clinical people always talk in terms of chance. So doctor will say is very critical stage of cancer. There is a 80% probability that he will survive only 6 months. So you prepare his will and whatever you want. So he talks to, so that chance. So the chance factor, the chance is nothing but your probability factor, right? Probability, we have taken 15 lectures. So this probability factor we are going to study today in a bit detail. So there are a couple of things I wanted to show you. So there are two things here. One is confidence interval and one is credible interval. Okay. So let us see what they are. What is confidence interval and what is credible interval? Both are very same thing. Both are almost same thing. But little difference is still there. Let us see what they are and what is the difference. Okay. Now you know the very first lecture was ours in statistics was frequentist. There can be two type of statisticians. Statistical people, statistics scientists, they can be of two type. Frequentist and Bayesian. We know that. So we have taken a complete lecture. So statistician, frequentist means they believe only on the current data. They take all the decision based on only current data they have. Bayesian guy will assume something that they will have a notion in his mind. Like I gave you nurse example. So in our hospital, you want to calculate the average age of nurse. Without calculating the data, without having any data, you are assuming that average age of nurse may be 15 years, 35 years by looking at their faces and all that. Okay, so you are assuming. And after that, you are collecting data. And then you are either rejecting that hypothesis of 35 years or you are accepting that as a hypothesis. So there is a prior assumption before, there is a prior assumption. So that when there is a prior assumption, and then we take that assumption and either reject that assumption or take that assumption, accept that assumption. That kind of things, when it is done, it is called Bayesian statistics. So when a frequentist statistic, like a guy who believes only in current data, frequentist guy, he tells that I am 95% confident that true estimate will lie between lower and upper limits of the interval. Okay. So true age of the nurse may lie between 35 plus minus 2 years. So upper limit is 37, lower limit is 33. So lower limit is 33, upper limit is 37, and true age of nurses may lie somewhere, true average age of nurse may be lying between 33 to 37. That's what we are confident. So it can be 33.5, 34, or 35, whatever. So average age we are talking about. So that is frequentist. So how will he believe? First, he will take interview of the nurse. All the nurses he will interview and ask their age actually, have their data. And in an Excel sheet, he will put and find their average. Then only he will believe. And then only he can tell plus minus something. But this Bayesian guy will, without taking the data, he will assume something first. That average age is 35 years. Then he will take data. And then he will try to either accept the assumption or reject the assumption. So what is the difference here? Now take the example here. Try to read these, for example, bullets, which are in smaller letters. Try to read these bullets. So we are talking about confidence intervals here. Okay. So confidence interval we are talking. So we are talking about Bayesian guy first. Confidence interval belongs to the confidence interval belongs to a frequentist guy. So frequentist guy belongs to a only data. He believes only in current data. He doesn't have any prior hypothesis or prior assumption. So let us try to read bullets with you. For example, suppose we want to estimate the average height of adult man in city. Adult man means above 18 in the city. City is very small. So we want to estimate the average height of adult man, only man, not woman. Adult man, we want average age. Complete city, we want the average. What is the average height of adult? That is the problem. We take a random sample of 100 men and measure their height. Full city, we cannot measure 10, 15 lakh people. Men, we cannot measure. The full population, we cannot measure. We have discussed it 100 times. Okay. So we take a sample of 100 men and measure their heights. Based on the sample, we calculate the sample height to be 175 centimeter. Sample we have taken, all the 100 people we have measured their height and taken the simple arithmetical average. Added all the heights divided by 100. So we got 175 centimeter with a standard deviation of 10 centimeter. 100 data points are there, right? So 100 people are there and there are 100 height of 100 people. So you have 100 data points. So you will have some standard deviation also. It's a variable with multiple values. Okay. So it will have average is 175 centimeter and the standard deviation is 10 centimeter. Now you know that if you know the average and standard deviation, you can completely define the distribution. You know that to define the distribution, you need only two values, average and standard deviation. So both we can calculate because we have measured the height of 100 people. We put in Excel sheet, apply formula, first calculate the average, we got 175. Then we apply second formula to calculate standard deviation, we got 10 centimeter. We can construct a 95% confidence interval for the population mean using the formula. So let us not go. So there is some formula given here. Let us not get into formula. Formula we'll see when we study numericals. So right now, let us not. So we calculate with some formula, we calculate the confidence interval. Confidence interval comes out to be 170.04 lower limit and higher limit is 177.96. Okay. So now a frequentist guy who believes only on data, so data is what here? Height of 100 people. So what that frequentist guy will tell, we are 90% for 95% confident that population mean height falls within this range. He will not tell that exactly. See, average sample average was 175, but we still don't know for full population how much it is. So based on this sample, we have to infer about population. So we have calculated a lower limit, which is 172.04, a higher limit 177.96, and then we are telling, a frequentist guy is telling that I am 95% sure that the average mean of population, now we are talking about population, will fall between 172.04 and higher limit is 177.96. That's how we will talk. Because population means more unknown. And sample mean, based on sample mean, we are inferring population mean. So that's how some formula is applied. And we got a lower limit and upper limit. And distribution was known. So we say 95% confident. So based on sample data only we have done. There is no prior assumption here. Got it, guys? Or is it little difficult to understand? There is no prior assumption here. Only we take a sample, take sample data. Based on that, we applied a formula, got a lower limit, got a higher limit. And based on that, we are inferring about population, saying that population mean, I am 95% confident that population mean is between 172.04, lower limit, and higher limit is 177.96. Sarthak, is it understood?
Yes, sir.
Amit,
Yes,
Jignesh,
sir.
and Shailendra, is it understood? Gajendra,
Yes, sir.
is it understood?
Yes, sir.
So now this frequentist guy, so what he is doing? He believes only in the current data. There is no prior hypothesis. There is no prior assumption. So this is one way of inferring about population. Okay. So calculate the sample, take the sample, calculate sample mean and standard deviation, apply one formula. That formula we'll discuss while discussing numericals. So right now, let us not worry about formula. Apply one formula, standard formula, get the lower limit, higher limit, and say that 95% confidence that population mean will lie between these two limits, lower and higher limits. So that is how a frequentist guy will work, who believes only in current data. There is no prior assumption here. Now let us see how Bayesian guy works. Bayesian guy, like next slide, again try to read the same example here. Bayesian guy believes in prior assumption. Without calculating, without taking any sample, he will say that the mean is something. Mean is 175. Without taking any data, he will assume first. And then he will take data and see, so how it see. Let us see how it works. Let us try to read with me. Suppose we have same data as before, like same example, same city, we have to calculate the average height of adult man. Now again, same data taken, 100 people are taken, 100 people sample is taken, their height is measured. So data in previous example and this example, data is same. Now let us see how Bayesian guys operate. But now we have a prior belief. Prior belief means we have a belief without prior belief that population mean height is normally distributed with a mean of 180 centimeter and standard deviation of 5 centimeter. This guy is a little more clever. He's not doing any measurement, and he's in his mind he is assuming that population is normally distributed. That is one assumption he has made. Second assumption he has made is that mean is 180 centimeters. And third mean is that standard deviation is 5 centimeters. So he thinks that he is a kind of mathematician or whatever he thinks himself. With some domain knowledge, some knowledge he might be having. So based on these three assumptions he has made. One, the height is normally distributed. Second, mean is 1 centimeter, 180 centimeter. And third, standard deviation is 5 centimeter. He assumed that thing out of air or out of some his domain knowledge he is having in mind. So from there, he assumed these three things. Then what he does? Based on Bayes theorem he applied, we studied Bayes theorem in one of our lectures. So I'll upload that lecture, you can revise that. Based on Bayes theorem and the data, we can calculate the posterior distribution. Posterior distribution means now we have some data because once we have taken the assumption and now we have data of 100 people sample. 100 people sample we have. So we applied Bayes theorem and calculate posterior distribution. Posterior means prior assumption plus data. Now we are getting a new distribution. So new distribution, what result we got? With actual data, what result we got? The mean is 175 centimeter and standard deviation is only 0.5 centimeter. So with the data and combining data and the assumption, apply Bayes theorem, and then we are getting new distribution mean as 175 centimeter and standard deviation of 0.5 centimeter. It is not same at what he assumed earlier. So now what he is concluding Bayesian guy? The 95% credible interval would then be 174.07 lower limit and higher limit is 175.93. He again applied some formula. That formula will bother later. So he again calculated the lower limit 175.4.07, higher limit of 175.93, meaning that we believe that 95% probability that true population mean height falls in this range. So he also did same thing. He calculated a lower limit, higher limit with some formula, and then said that I am 95% confident that population mean. Now we are talking about population mean. Population mean lies between 175.07 lower limit and higher limit is 175.93. So now he is also doing same thing as frequentist guy, which previously also we did same thing. But the method is different here. What method is different? First of all, he is starting with a assumption. What assumption? That height is normally distributed. Assumption that mean is 180 centimeter. Another assumption that standard deviation is 5 centimeter. He is starting with the assumption. Then he is applying Bayes theorem on the data, and then he is calculating the actual thing, posterior. Posterior means actual after applying data. So posterior he got that mean is only 175 centimeter and standard deviation is 0.5 centimeter. He's applying some formula, calculating lower limit and upper limit. So method of calculation is different. So it is when a Bayesian guy does this with a prior assumption, we call it credible interval. We call it credible interval. And same thing in previous example is confidence interval. When a frequentist guy does, we call it confidence interval. And when same thing a Bayesian guy does with the assumption and then takes data and calculate, we call it credible interval. Okay. So today's clinical world, let us go ahead. Okay, confidence interval represent. So guys, you got the difference between confidence interval and credible interval, guys. You got it? Sarthak, Amit?
Yes, sir.
Only the method of calculation is different. Other things are same. Amit, Gajendra bhai, you got it? Jignesh bhai?
Sir, I have one doubt.
Yeah,
That
tell
line,
me.
second last line, the
Okay.
posterior distribution, right? He
Okay.
got the data 175 centimeter and 10 centimeter. Then range will be similar as a confidential, right? Below range.
No. This formula this time is different here.
This is a posterior distribution for different formula.
Posterior, in case of Bayesian, this is the Bayesian, so formula will not be this. Formula will be different.
Okay.
So we'll bother that formula when we'll come to numerical examples. Okay.
Okay. So formula is different for the
Formula is
posterior.
different. So this time see, frequentist got the range as 172.04 and higher range as 175.96. So it was a wider range. And this guy got range as 174.07 as lower and higher is only 175.93. So it is a narrow range. Formula is different here.
So here formula name is a posterior distribution, and in the
No.
confidential.
Posterior distribution, the result we are calling as posterior distribution.
Okay.
The result we are calling as distribution, posterior distribution.
Okay.
Distribution means what? Mean and standard deviation.
Yeah.
So prior distribution was assumption 180 centimeter and standard deviation of 5 centimeter. Then posterior distribution means after that, whatever we did calculations with the Bayesian formula, we got a mean of 175 and standard deviation of 0.5. So that is after applying formula on the data, we got this result. So that is called posterior distribution.
Yeah.
That result is called posterior distribution. Got it? Result and distribution.
Yeah. Okay. Mean is just mean and the standard distribution data will be same in both. Then also result will be different, right?
No. See, in frequentist case, mean is same, but standard deviation is 10 centimeter.
Yeah.
And
Yeah,
in
but
this case, mean is 175 only, but standard deviation is only 0.5 centimeter.
Yeah. So my question is that if the standard deviation also 10 centimeter, then result will be similar, or it will be different.
Then I think it should be similar.
Okay.
If frequentist also is having 10 centimeter standard deviation, then I think real result should be similar.
Okay. And the 175 centimeter and 0.5 centimeter, the deviation, he is getting the different deviation if they have collected same data and same number of.
But method of calculation is different. That's why he's getting a different result.
Okay. Therefore, standard deviation is different. Okay.
Yeah.
Okay.
The method of calculation is different.
Okay.
Okay. So confidence interval represents a range of values that we are fairly confident that true part. So based on sample data. So confidence interval means there is a lower limit and a higher limit, and we are confident with some probability that true value will lie between these lower and higher limits. So that is based on sample data. In credible interval also we have same thing. But we are doing it with the help of data. We have data also, and we have some prior assumption also. So first one is called frequentist, and the second one, which is credible interval, that is called Bayesian. Got it, guys? So that is the only difference. First method is based on only sample data, frequentist. Second method, we have sample data also, and we have a prior belief also, prior assumption. Prior hypothesis also we have. So that is the difference of calculation. So second one is Bayesian and first one is frequentist. Got it, guys? Any challenge in this?
No, sir.
So now these two slides, I'm not confusing you anymore because you have understood. So these two slides, when I share the slides with you, you can study on your own. See, clearly difference is given here. See, clearly difference is given here in very detail. And this slide also gives more details. So you can read it and then come to your with difficulty. Because you have understood, that's why I don't want to confuse you further with more details. So I'm skipping these two slides for now. Okay. So now, now estimation of statistical parameters. In statistics, estimation refers to the process by which we make inferences about population based on information obtained from a sample. We take a sample, do measurements on sample, like we measured, like in the case of height, we took a sample of 100 people. We got from sample itself, we got height as mean as 175 and standard deviation as 10 centimeter for frequentist. Standard deviation is 10 centimeters. So sample calculation we did, and based on that, we did confidence interval formula. So we calculated a lower limit and a higher limit and told that we are 95% confidence that population height will lie between this lower limit and higher limit. That's what we did. So this is the complete process of making inferences about population. We are taking inferences about population based on measurements or information taken from the sample. We are taking measurements from the sample and making inferences about the population. So complete process now you got here. So this is the complete process, guys. This is the complete process of making inferences. So this is the complete process. So when we talk about population, we are making inference. So we talk in limits that we are 95% confident that population height will be in the lower limit between lower limit and higher limit. 95% confidence, like that we talk. Because we are not sure. Because why we are not sure? Because we have not measured 100% population. We are talking about population based on our calculations of sample. Based on sample, we are talking about population. That's why we take some probability and lower limit and higher limit. But sample, we are 100% sure. Why? Because sample only 100 are there and we can measure what is the real standard deviation and what is real average. We can calculate. So sample, we are 100% confident that average is 175 and standard deviation in 10 because we have measured in Excel sheet. We have done measurement ourselves, but population, we are not sure. So based on sample measurements, we are taking inferences about population measurement. So we talk about probability that we are 95% confident that population height will lie between 172.04 lower limit and higher limit 177.96. Like that we talk in terms of probability. Why we talk about probability and limits? Because we are not done actual measurements on population. Okay. So this method, this complete process is called estimation of statistical parameters. So if you remember, guys, I told you one rule of thumb, PPSS. So when we do any measurements about population, it is called parameter. And when we do any measurement about sample, it is called statistic. So PPSS formula, if you remember, in one of the lectures, I gave you this rule of thumb. So first we calculate statistic based on sample, and then we go for a parameter, population parameter. So this method is called statistical measurements. So now these are the main steps. So when we make statistical inference about a population, so one line goes to estimation. So estimations are of two types, point estimation and interval estimation. We'll study them in the next slide. And another step goes to test of hypothesis. This also we'll study down the line in today's lecture. So first, try to understand the structure. Statistical inference about population based on sample data is divided into two steps. One is estimation and testing of hypothesis. So estimation is point estimation or interval estimation. So both are a simple concept. You already know them. So let us study what is point estimation and what is interval estimation. Okay. So try to read these columns with me. So point estimation. Only see the example, guys. Don't read any other. So there are, see, second bullet, there are example. So see what is the example of point estimation. Average salary of junior data scientist is 50,000 euros. We are talking only 1 point here. We are talking about only 1 point. There is no lower limit, higher limit. We are concrete data we are talking. That average salary of a junior data scientist, maybe in Germany or England, is 50,000 euros. England, there is no euros. England, they go for Great Britain pounds. So suppose the data is for Germany. So we talk about average salary of junior data scientist is 55,000 euros. Only one data point, concrete data point. There is no lower limit, no higher limit. So this is called point estimation. Now see the second like in second column. You see only the example. How we are telling? Same thing now we are telling that every example, average salary of junior data scientist in Germany is in the range of 52,000 lower limit and 55,000 upper limit. So now we are talking about limits. Lower limit 52,000, upper limit 55,000 euros with 95% confidence interval. So this we have already studied. So this, when we talk in this way, that is called interval estimation, because we are talking in terms of interval. What is the interval here? 52,000 lower limit, 55,000 upper limit. That is the interval. And what is the confidence level? 95% confidence level. So when we talk in this language, then it is called then we call interval estimation. So point estimation. So point estimation will always lie between interval estimation. That point estimation will always lie in between, somewhere in between interval estimation. We can say that point estimation of 55,000 salary with the lower limit of 52,000 and upper limit of 55,000 and confidence interval 95%. So point interval will always lie between somewhere in the interval estimation, lower limit and higher limit. That's where point interval will lie, in between lower limit and higher limit. Now what is hypothesis? Testing of hypothesis. You know nothing about Germany. You are sitting in Delhi or you are sitting in Bangalore and you are claiming, you are making a claim without knowing any data, without knowing Germany, you are making a claim. Or you know Germany a little bit. You are making a claim without any data, but without any data, you are making a claim that average salary of a junior scientist is greater than 50,000 euros annually. You are making a claim here. There is no basis. Only from your domain knowledge in your mind, you are telling that average salary, see the difference. Average salary of junior data scientist is greater than 55,000 euros annually. You are making a claim here. There is no basis. Got it? So that we have to either prove or disprove with the help of data. This is a hypothesis. Hypothesis is what? Average salary of junior data scientists is greater than 50,000 annually. This is a claim. So this is an assumption. This is a hypothesis. Now, with the help of actual sample data, we have to either reject it or accept it. That is the full theory of hypothesis. Okay, that's how we do. So now, three ways of making the same claim. One is point estimation. Point estimation means I'm in HR industry. Maybe I'm dealing with junior data scientists day in, day out. I'm an HR guy. So I know that average salary is in Germany is around 55,000 euros. Only making 1 point data I'm talking. I know it definitely it is like that only. Now, I'm a statistical guy. I want to be play little more safer. So instead of giving that it is 55,000, I talk in a different language. What language I use? See the middle one. The average salary of junior data scientist in Germany is in the range of 52,000 to 55,000 with 95% confidence interval. So this is a perfect statement by a statistician or a mathematician. He wants to be safer and he wants to be a correct only. So he wants to give a correct statement and he wants to be on safer side. So he's talking in the terms of range and confidence interval. That is one way of telling. And now this is like maybe some politician. So politician never talks, generally they don't talk in terms of mathematics. They generally make claims. Okay. So now a politician is making a claim or some guy is making a claim that average salary of junior data scientist in Germany is greater than 50,000 euros annually. He's making a claim. So three ways of telling the same thing. They all are telling same thing, but in a three different ways. So point estimation and interval estimation are very much related. So point estimate will always lie somewhere in between the lower limit and the higher limit. That's how they are related. But hypothesis testing is different branch. So where you have a claim is what? Claim or hypothesis. What is average salary of junior data scientist is greater than 50,000 euros annually. So this is a claim or hypothesis. Now you will collect you will go to Germany, maybe some data you will collect in Germany, and then with the help of that sample data, you will either accept this hypothesis or you can reject this hypothesis. That's what. So these are three kind of things like. Is it understood, guys? Very simple concepts, but important concept, guys. Are they understood?
Yes, sir.
Yes, sir.
So
Yes,
important. See, I am not preparing you for any exam. I want you to understand statistics. I want you to appreciate the statistics in your life. If you are in a data science or in your life, even if you are not a data scientist, it is good to know statistics. I want you to appreciate the subject. I'm not preparing you for any exams here. Okay, guys. So let us go next. So now we know about point estimate and interval estimate. So little different way of looking at it. So point estimate means we talk about sample mean is 50,000. Sample proportion is something A by B. So A by B is say 2 by 5. Simply we talk in terms of single number. Interval estimate, we talk about intervals, confidence. First of all, like either lower limit, upper limit, and a confidence level. That's how we talk. So now we know this point estimate and these estimates. Then this is also, I think I can skip. So this is how it works, guys, process. So you have some scientific knowledge. You have your reasoning in your mind because all of you have studied physics, mathematics, and chemistry up to 12th level or even beyond. So you have considerable knowledge or reasoning capacity in your mind. Then you can formulate some hypothesis about something. Like without measurement itself, you can assume something that average age of nurses in this hospital may be 35 years. That's what is assumption you are making. And then you take some observations. You collect a sample of 20 nurses, ask their age, and then based on that, you test the hypothesis, whether is it really 35 years or it is 40 years. If your sample mean is more, then you can reject the claim that it was 35 years. Then you have to accept based on data, whatever comes. Posterior you have to accept. Okay. So that's how it works. So that's how we have done this. So like again, one other view, same thing now you know. You form a hypothesis. First you make a claim that average salary of data scientists in Germany is is greater than 50,000 euros. You make a claim. Then you collect data from Germany to test that hypothesis, whether it is really 50,000, is it really greater than 50,000, or is it 50,000, or is it less than 50,000, based on sample data. Then either you accept the hypothesis or you reject the hypothesis. So this is the entire process of making statistical inferences. So you should understand how statistics works. So statistics work this way. This is Bayesian statistics, right? So now let us go to, I don't want this slide. Now I want you to get into little technical. So now we are getting little technical. So now hypothesis testing, you know what is the process. You make a hypothesis, you make a claim that average salary of data scientists in Germany is greater than 50,000 euros. You make a claim. So that is your hypothesis. So that is called null hypothesis. Whenever you make a claim like that, you call it null hypothesis. I'll give you a lot of examples of null hypothesis so that you understand. And there will be alternate hypothesis contradicting that. So null hypothesis was data scientist in the average salary of data scientists in Germany is greater than or equal to 50,000 euros. In null hypothesis, equal to will always be there. So it will be either greater than, equal to, or less than equal to, or greater than equal to. Equal to sign will always be there. Either only equal to, less than equal to, or greater than equal to. See the bottommost here. It can include either equal to, less than equal to, or greater than equal to. Null hypothesis will be opposite of it. Not equal to, simply greater than, or less than. So what will be our null hypothesis in this salary case? The null hypothesis will be the average salary of junior data scientists in Germany is not equal to $50,000. Is not greater than $50,000. Like that you will make. Opposite of null hypothesis. So null hypothesis is something you make the claim. Whatever claim you are making is your null hypothesis. So it can be absurd also. Like something is made, somebody is making some claim. So that is null hypothesis. And whatever you want to prove with the help of research, like you are a researcher and you know a little bit about Germany. So Sarthak will say that somebody has made that then the average salary of data scientists in Germany is greater than or equal to 50,000 euros. But Sarthak has some data, Sarthak has some sample. He will tell, he will try to prove. Sarthak is a researcher, so he will prove that average salary of data scientists in Germany is less than 50,000 euros. He will make an opposite statement. And with the help of data, he will prove his research question. So, alternate, there are two things. Either one thing is null hypothesis, other thing is alternate hypothesis. One is called H0, and other is HA or H1. So they are opposite of each other. So I'll give you more example. Remember one thing, in null hypothesis, there will always be a equal to sign. So either equal to, less than equal to, or greater than equal to. In alternate hypothesis, equal to will never be there. So it will be either not equal to, greater than, or less than. So I'll give you more examples. See now common language example. Somebody has, like broadly, like somebody is not a scientist, a common man. Like common man, I make a statement. Light color has no effect on plant growth. We're talking about plant growth, and I'm making a claim that light color, whether it is a blue light, a red light, or a green light, or a white light, or whatever color is. So color doesn't have any effect on plant growth. If I say, if I put a green light, the growth will be same. If I put a red light, the growth will be same. If I put blue light, the growth will be same. If I put white light, growth will be same. So color of light has no effect. But now you are a researcher. Sarthak is a researcher. Now he will come and tell. So null hypothesis is what? Null hypothesis is light color has no effect on plant growth. That is null hypothesis. So that is what we have to either accept or reject with the help of data. Either we have to accept or do not accept. Accept or do not accept. There is no reject. So either accept or do not accept. Okay. So what is the alternate hypothesis? Light color affects plant growth. So that is exactly opposite of null hypothesis. Got it, guys? How to form null and alternate hypothesis? Got it, guys?
Yes, sir.
Yes, sir.
So null hypothesis, either we have to reject, no, we don't reject it. Either we accept or we don't accept it. And research and alternate hypothesis is the research question that we want to prove. So now a layman is making a claim that light color has no effect on plant growth. He is making some absurd statement. But a researcher wants to prove that opposite, he wants to prove that light color affects plant growth. So they are opposite. That is one example. Another example you see. First see the right hand side. Right hand side is null hypothesis. So there is some common man or some absurd guy making a statement that application of biofertilizer X. So they are talking about some brand of fertilizer. So application of biofertilizer X do not increase plant growth. So he is the statement made by some pessimist guy or some guy who doesn't know much about that particular biofertilizer. So he is making a statement. Biofertilizer, application of biofertilizer X brand do not increase plant growth. It doesn't have any effect on plant growth. So he is making a statement. So that is your null hypothesis. So your alternate hypothesis will be opposite of it, H1. So H0 is what? H0 is application of biofertilizer X do not increase plant growth. Okay, so that is a negative statement. That is your null hypothesis. And your alternate hypothesis will be opposite. Application of biofertilizer X increase plant growth. So H1 or alternate hypothesis will always be opposite. Got it, guys? Got it, guys? Amit bhai, Rajendra bhai, got it?
Yes, sir.
So first we should know how to formulate H0 and H1. Then only we can proceed. Very important. Given a problem, we should first be able to formulate H0 and H1. Then only we can work with numerical examples. So you should know how to formulate H0, how to formulate H1. Then let us take more examples. Like this example I don't want to take. Like take this example, guys. I want to take this example. So, okay. So here, don't see, I see first row is very confusing. So read second one. Do cat care about shape of their food? So question is, do cats care about shape of their food? So same thing is given. So if shape is different, do they care about it? So what is null hypothesis here? So null hypothesis is cats show no preference based on shape. Cats show no preference based on shape. Somebody has made a claim. Cats show no preference based on shape. Whatever is shape, they are not bothered. Now alternate hypothesis. Cats show a food preference based on shape. See, if we are humans, if some food is placed, same food is placed in front of us, we care about shape, right? If it is a pleasant shape, nicely cut shape, equally cut shape, then we like it. We like to eat it. If it is absurdly cut, some sweet is small, some sweet is big, and their shape is absurd, then we don't like to eat it. We may not like to eat it. But now here we are talking about cats. So null hypothesis, cats show no preference based on shape. Alternate hypothesis, cats show food preference based on shape. Exactly opposite. Now see the second one. Do teens care about, teenage people, teenage guys, do teens use mobile devices more than adults? We know that teen use more than adults. We know that, right? Generally teens are very heavy users of mobile. But see how to form the null hypothesis. Teens and adult use mobile devices the same amount. Teen also use 2 hours and adult also use the same amount, 2 hours. That's what is the claim made. So that is H0, your null hypothesis. So what will be your alternate hypothesis? Teens and adult use mobile devices in different amounts. That is exactly opposite of that. Okay, so now see the last one. I'll put pictures somewhere else. So now the last one is, do color of light influence the plant growth? We have seen this. Does the color of light influence plant growth? So our null hypothesis will be, the color of light has no effect on plant growth. Generally some except statement. Color of light has no effect on plant growth. Some random statement. And alternate hypothesis will be your research question. The color of light affects plant growth. That's how, like first, given a problem, first problem is to how to form null hypothesis and alternate hypothesis. That's how we should learn. So I'm giving you some examples. So here things to learn is, you learn here H0 and at the bottommost you read now. H0 will always have equal to, less than equal to, or greater than equal to. Equal to sign will always be there. Either only equal to will be there, or less than equal to will be there, or greater than equal to. So equal to will always be there in null hypothesis. Alternate hypothesis, equal to will never be there. So it will be either not equal to, simple greater than, or less than. Okay, so equal to will not be there. So that's how you have to, this is the trick actually. So you have to remember this while forming. So when we'll do numerical examples, we will now. So now there is a difference between null and alternate hypothesis. So assumption, like first null hypothesis H0 and alternate hypothesis is represented either by HA or H1. Generally H1, but here he is talking about HA. So what is the difference? H0 represents assumption, some assumption, random assumption, status quo, nothing new. There is nothing new in it. Light has no effect on plant growth, like some random statement. But HA will be exactly opposite of H0, rejection of an assumption. Whatever assumption is being made, H1 will be alternate hypothesis, will be opposite of that. H0 is assumed to be true or given. So there will be some, like it will be a given statement kind of thing. It will not be a research question, H0. H1 will be rejection of an assumption. Whatever assumption is being made, you are rejecting that assumption. That will be HA, H1. Then see the last one. Always contains equal to, less than equal to, or greater than equal to. That is about H0, which is a null hypothesis, and does not contain equality. HA means alternate hypothesis will not have equal to sign. It will have not equal to, less than, and only greater than sign. So when we'll see some problems, we'll learn how to form null hypothesis and how to formulate alternate hypothesis here. So see, so now here one more summarizing. You can read on your own. The null hypothesis always be following sign: equal to, less than equal to, or greater than equal to. Alternate hypothesis will always have following signs: not equal to, greater than, or less than. So right now, I am trying to explain you null statement will be some guy giving some random statement. Okay, some absurd statement, some negative statement, some random statement. And alternate hypothesis will be opposite of that. You want to reject that particular assumption with the help of data, whatever. Okay. So how you talk? Either you accept the null hypothesis or reject or do not accept the null hypothesis. But reject is never used. You either accept the null hypothesis or do not accept the null hypothesis. Reject is never used in Like we never talk this way, that we are rejecting null hypothesis. No. We'll either accept the null hypothesis or we do not accept the null hypothesis. That's how we talk in mathematical language. Okay. So this is another way of putting the same thing. See, in null hypothesis, see the middle one. Typical phrases used in null hypothesis. So null hypothesis will have phrases like no effect, no difference, no relationship, no range, no change, does not increase, does not decrease. Some kind of this kind of phrases will be there in null hypothesis. Alternate hypothesis will be opposite. So what kind of phrases it will have? An effect, a difference, a relationship, a chance, increases, decreases. So it will be a little bit concrete and positive kind of thing. So it will be exactly opposite. Once you form null hypothesis, then forming alternate hypothesis is very easy. It is just opposite of it. Okay. Then symbols, like there will always be equality, equal to sign in null hypothesis, equal to, greater than equal to, or less than equal to. And alternate hypothesis will be, there will not be any equality. So now not equal to, less than, or greater than. Okay. So this is the overall process. I'm not going into process, I think, because see how you go. First of all, you form your null hypothesis, H0. Some random abstract statement is null hypothesis. Then you state the alternate hypothesis. Opposite of null hypothesis is your alternate hypothesis. So you have now H0 and HA. So now you have to find the C. When you are rejecting null hypothesis, when we are not accepting null hypothesis, you are still having some risk, right? 5% risk or 10%, 100% you are not sure, because you are never measuring population. Based on sample only you are inferring. So you still have some risk. So you have to define your risk first, then risk, 5% risk, 10% risk, like that. We'll see how risk, this risk part we'll see more in numerical examples. So determine your sample size, take your sample size, take your data, from sample size you collect the data, run the appropriate hypothesis test and decide whether to reject your null hypothesis or fail to reject your null hypothesis. So this is our full procedure. This is the theoretical procedure. We'll see while doing. It will be more clear when you will do numerical examples. So you either reject your null hypothesis, reject or fail to reject your null hypothesis. This is how you talk. Sorry, I took a different language. So either you reject your null hypothesis or fail to reject your null hypothesis. That's how you have to talk. Previously, I talked a little bit wrongly. So sorry about that. So you talk in this language. You either reject your null hypothesis or fail to reject null hypothesis. You either reject your null hypothesis or fail to reject null hypothesis. That's how you talk. I think today is enough.